Okay, we are moving on again to probably one of my favorite parts of statistics. Okay, this is a normal distribution. Okay, this is on page 7 in your packet. Okay, y'all just turn the other way, so go ahead and turn your page, obviously. Turn it sideways so you can see it. Okay, this is a normal distribution. We talked about it a little earlier when we were talking about things being skewed. Okay, so this is perfect world. All of your data is symmetrically placed right here, okay, on this, what we call the bell curve. I'm sure y'all have heard that before. Okay, so normal distribution, a definition, let's just put perfect world data. Okay, again, this is where if you split it straight down the middle, 50% of your data is on one side, 50% is on the other side. Okay, obviously we know that doesn't really happen, but again, this is what we're going to call perfect world data. Okay, with your normal distribution, okay, like I said, right here is the middle of my bell curve. Okay, in the middle of my bell curve is where my mean goes. Okay, that is where your average is. This is the average that separates the lower half of your data from the upper half of your data. Okay, if you see these little tick marks that are separating the curves here, that is one standard deviation away from the mean. Okay, so let's think back about Bryce and Brianna. Okay, and we said that Bryce had a standard deviation of 7.83. Okay, so standard deviation of 7.83. You would take whatever the mean is, add 7.83, and that would give you the scores that are falling right here. Add another 7.83, and that gives you the scores right here. Add another 7.83, and so on. Okay, obviously if you go to the left, you're going to subtract that same exact situation. Okay, for right now, we're going to do this. I'm going to say that this is positive 1 standard deviation away. This is positive 2. So basically we've added the standard deviation twice. And now we add it 3 times. Going the other way, we subtract the standard deviation once from the mean. We subtract it twice from the mean. And we subtract it 3 times from the mean. Okay, again, perfect world, all of our data would fall under this curve right here. You would have no crazy outlier over here. Okay, it's again, perfect world, all falling right here under the curve. Okay, so to work with a normal curve, go ahead and put this. Step 1, list the mean. Step 2 is going to be to label your standard deviations, which I said I'm going to abbreviate like this because I'm lazy and don't want to write it out. Okay, step 3, we are going to label our percentages, which you will see in just a second. Okay, we're going to label our percentages. We're actually going to do that on the next page. Right now we're just going to talk about what it looks like to work with a normal curve. Okay, clearly you can look at both of these and see that they are completely different shapes. However, they are still each symmetrical. Okay, if I would fold the paper right here along where we know our mean goes, okay, and I fold this one right along this dot where our mean goes, they're still both absolutely symmetrical. They look different from each other, but they are symmetrical within themselves. Okay, so here's what we're going to do. Step 1 again says to label the mean. I know the mean is in the middle. It tells you right here that this first curve has a mean of 20. So my average for whatever kind of data this is has an average of 20. And then it says every step away from that you add 10 or subtract 10. Okay, so if I take one step away here, I'm going to add 10, which puts me at 30. One more step puts me at 40. And then this tiny little line over here puts me at 50. Okay, on the flip side of that, I have to go fill in the other direction too. Okay, if I go the other way, then I'm losing 10 points or whatever this happens to be. So from 20, then I go down to 10. Then I go down to 0, and then I go down to -10. Okay, that's this curve right here. That's this little fella. Okay, coming over here to this curve. Okay, this is another way to list the mean and the standard deviation. The average is first, the mean is first, so we have a mean of 10. And then in this case, our standard deviation is 2. Okay, so when we take one step away, we add 2 and get 12. And then 14, add another set of 2 and you get 16. Okay, same thing going the other way. You subtract 2 and you get 8. Subtract 2 more, 6. Subtract 2 more, end up with 4. Okay, so look at these two curves right here. Again, both are perfectly symmetrical. It is a perfectly shaped bell curve. But this guy right here is kind of stretched out. Okay, this is more like a speed bump, and then this is, Mount Everest over here. Okay, it asks you which one has more spread. Which one is more spread out? Okay, well, looking at them, you might think this one is more spread out because he's taller. But what they're really talking about is length. Okay, how much data does it cover? This one covers all the way from a -10 all the way up to a +50. Okay, this guy over here covers from 4 up to 16. Okay, so whatever kind of data they gathered for these two bells or these two curves, this one was much more spread out than this guy was. Okay, so the one that has more spread is the first curve. Okay, he obviously has a larger standard deviation too. The steps that we took away from the center or away from the mean were bigger. This guy's steps were only 2 and his steps were 10. Okay, does everybody see that happening right there? Okay, we are taking much longer strides on this bell curve than we did on this bell curve. Okay, look down here at this example right here. This one is asking which one has a larger standard deviation. So we're looking for which one has wider strides. Which one did we take bigger steps? If you look, they both have the exact same average. Okay, ooh, that was a rough line. Okay, the middle of my graph is the same for both of them. Okay, both graphs have a mean right there. Okay, curve 1 is kind of like the one above. He's super tall. Okay, tall and kind of skinny. And then the other one is shorter and definitely more spread out. Okay, which means that curve 2 had the wider strides, giving us the larger standard deviation. Okay, question's a little different down here. Let me zoom in. Okay, this one wants to know which curve has a larger mean or a larger average. Okay, here is my scale down here at the bottom. I believe it's going by 5s. Kind of hard to see, it's a little cloudy. Okay, but these two right here have the exact same average. Okay, their mean is falling right here. Two different curves, but their means are the same. And his mean is right here. Okay, so if you think about this as a normal XY graph that y'all are used to seeing from elementary school, okay, this graph over here, AB, this is curve C, has the larger average or has the larger mean. Okay, looking at it, it looks like curve A and curve C have the exact same standard deviation. They look like the same curve, it's just one has been moved up more. Okay, maybe this was a pre-test and this was a post-test, okay, before you learn the material, and then curve C was after you learn the material, so everybody's grades went up. Who knows? Okay, just realize that the middle represents the mean or the average, okay, and then the standard deviation controls how wide your graph is. Okay, let's flip it and talk about some percentages. Okay, let's go through and fill out the bottom of this curve number 1. Okay, let's fill out the bottom of him based on the data that they give us. Okay, they tell us it has an average of 120, so he goes right here. And that our standard deviation is 8. Okay, so if I have 120, and my first step is going to take us 8 points. Let's say these are points in a, I don't know, bowling league maybe. Okay, it's going to put us at 128. And the next step is going to put us at 136. And then at 144. Okay, on the flip side of that, going backwards, we end up at 112. And then 104. And then at 96. Okay, here's where the percentages come in. Okay, here's where it becomes really tricky and something that I had to memorize when I was in school. Okay, again, y'all know that this line right here breaks it up into half and half. Okay, but what about each individual chunk? Okay, what about if I wanted to know what's going on between this piece and this piece right here? It's not 50%. Okay, 50% would be the whole right side of my graph or the whole left side of my graph. Okay, so here's how the percentages break up. And they are exactly the same on both sides. And then this tiny little tail right here is 0.15% of our data. Okay, and then it repeats on this side. Okay, so this chunk of data right here between 120 and 128 is 34% of our people. Okay, 34% of our bowlers scored between a 120 and a 128. 2.35, and then again 0.15. Okay, so there's bigger ways to chunk it up. Okay, from here to here is obviously 68% of our data. And then that's really hard to read. Okay, so one step away from the center in both directions gives you 68% of what is happening on this curve. Okay, so from here to here, again, like I said, is 68%. Okay, if you take another step away and you go to this standard deviation, sorry, I had to sneeze. Okay, if you take one more step away, you end up with 95%. And then the final step that takes you almost all the way out to the edge, but not completely, is 90. Type the wrong thing in. 99.7. Okay, so remember, the reason we're not at 100% is because we still have these two cute little tails right here. Okay, these little babies of 0.15%. Okay, if you would add those 0.15, you end up with 0.3, which would give us the entire 100% of our data that falls under this curve. Okay, but the important thing is, one step away from the middle is 68%, 2 steps away is 95%, and 3 steps away gives you the 99.7%. Okay, so almost all of it. Okay, that's important because of the questions that we're about to answer. Okay, it says, what is the 68% range? Okay, what percent of our, or what points did people score that made up 68% of our data? Okay, so look up here, I made my little chart. 68% of my data is from this line to this line, which is a score of 112 up to 128. Okay? Again, that was 112 up to 128. Okay, the 95%. 95 is from this line all the way out to this line, okay, which is 104 to 136. Okay, so 95% of our bowlers in this league can score between a 104 to 136. Okay, one more step out, 99.7 range is from the next steps, which is a 96 all the way up to a 144. Okay, so if I ask you, in order to be in this league, you have to be able to score between a 96 and a 144, because that's where 99.7% of our bowlers fall. That would be a true statement based on this bell. Okay, based on this curve right here. And the next thing is they're asking you for the percentages. They don't want ranges. They want to know what percent falls below 136. So they want to know how many people scored from 136 less than that. Okay, so they want to know what's going on this whole part of the curve right here. Okay, so we can take up our calculator and say, well, that's 13.5 plus 34 plus 34 plus 13.5, and add up all these percentages. And that is 97.5% of our data. Okay, so 97.5 of our bowlers scored from 136 or lower. Okay, an easier way is to say, well, I know that my whole curve is 100%. Whoops. Okay, and from 136 down is everything except for these two little values right here. So you could say 100% minus the two that are not included. And you should get the same answer if you type it incorrectly like I did not. Okay? So you should get the same answer no matter which way you do it. It doesn't matter. It's preference. Okay, the next question asks us above 128. Okay, here's our 128. What percentage is above that? So I go from 128 and I add up everybody that's above that line. Okay, here's my line. Everybody above that. So I have 13.5, 2.35, and my tiny little tail of 0.15. And that is 16% of people. Okay, 16% of my data is above scoring 128. Okay, what percent is above 104? Again, two different ways to do this one. 104, you can add up everybody that's above that. Or you can say the whole curve is 100. I am leaving out that 2.35 and that 0.15, and you will get the same answer. Oh, I left off my phone. Okay, so you'll get 97.5. Okay, again, this is asking for above 104, so draw yourself a little line above 104, so all of these percentages added up, subtracted from a 100, or subtract from 100, you'll get the same thing, and it was 97.5. Okay, below 128. 128, everybody below that. I have 34, plus 34 plus 13.5, 2.35, and 0.15. We are talking about 84%. Okay, below 128, 84%. Okay, between 104 and 128. So between 104 and 128. So we're looking at these three values. Okay, I have 34, and a 13.5. Okay, so between a 104 and a 128, 81.5. And the last one on this side is between 112 and 144. Okay, between 112 all the way up here to 144. Okay, so 1, 2, 3, 4 values to add up. 34 plus 34, 13.5. And that is 83.85%. Okay, it is excluding that 0.15. Okay, we went from 112 to 144, not beyond that. Okay, so 83.85. Okay, let's fill this one out together, and then I'll leave y'all to do these problems on your own. Real quick, scroll down. Look down right here. Erase that 128. Okay, this was obviously copy and pasted from this side over here, and that 128 never got erased. Okay, so this is supposed to say what percent falls above 43.4, and not that crazy 128 thrown in there. Okay, so let's fill out this curve, and then I will let y'all work on it on your own. Okay, my average is a 49. My standard deviation is 5.6, so I'm going to add 5.6 with every step I take to the right. And then I'm going to go back to my middle, and I'm going to subtract 5.6 with every step to the left. Oops. Remember on the first page, I told you the steps in setting this up. Okay, label your average, label your mean, label your standard deviations, and then go back in and label your percentages. Okay, so 34 in each of these, 13.5 in each of these, 2.35 in my little babies here, and then of course my tiny tails, 0.15. And again, let's do the steps over here. Okay, one step away is my 68%. 2 steps away is 95. And then of course, almost all the way out to the edge is my 99.7. Okay, so go ahead and take a minute, fill these in. Fill these in, check with your neighbor, and tomorrow when we come back, I will show you the answers.